All right, welcome to Waka Waka Breaking It Down. And this one is about solving rational equations. So, an equation with fractions in it, but more than that, fractions that have a variable in it. So, solving an equation with fractions. All right, so let's get to it. As always, this is the answer key here. And in the answer, so make sure you should go do this on your own first, right? And give it a try. And then you can see what worksheet we're talking about here. And then after that, come back if you're having trouble, of course. So always try it on your own first, but don't spend outrageous amount of time. And then when you get stuck, you come watch this video, right? Or if you just want reinforcement, it's really good for just reinforcing your thinking because I might point out some things you didn't see before on your own. Okay, so here we go. We got a variety of problems. They all have their little thing about them. This particular one, and they're looking at kind of different ways or whatever maybe, but really these have something in common about them, the one on the left and the one on the right. So this one is talking about these two problems are talking about how you already have a common denominator. And the thing to notice really is that you have an equal sign in between these. So these are not just two fractions that you're simplifying or that you're adding or subtracting or even multiplying. You are saying these are equal. So it becomes an equation instead of an expression. An expression does not have an equal sign. An equation does. So this is an equation. The left side equals the right side. It's important to keep that in mind. It determines some of the things you can and can't do, right? So now that if I have any fraction, like these are just different things you're going to see. If I have a fraction on each side that has a common denominator already, this is one of the easier cases because now you can just say, well, the tops just have to be the same. If this is 8 over 10 then and they're equal to each other, then this better be equal to 8, right? To make 8 over 10 as well. So when you solve, you can kind of ignore the bottom and just say, well, let's just make the tops equal to each other. And then I'll divide by 2, right? So 8 equals 2x, just the tops. Divide by 2 to solve, and you get 4. So you can see up here, if I put 4 back into the x, I'll get 2 times 4 is 8. So I'll have 8 tenths equals 8 tenths. I know it works. You can always check your answers on these. That's the good part about solving. You can go back, you can put in that value, and you can actually see that it works or it doesn't work. If it doesn't, then you did something wrong. If it does, then you can feel confident that you got the right answer. All right, the one on the right, same thing. It's not a number though, but it does have a common denominator already. You can see that those x plus ones are the same. So I don't really need to do any extra work really, but I do need to find out what makes the tops the same. This is 5 over that. So how do I make this one equal to 5 as well? Well, that's pretty simple solve. You just take the tops, subtract your 3, and you'll get 2. And of course, if you plug 2 into x, you'll see 2 plus 3 is 5. So they match. 5 on the right, 5 on the left. They are equal to each other. It's kind of your check, right? Okay, so that's when you already have common denominators. What happens if they are not common? Well, you probably want to make them common. So on the left, we have a 7. On the right, we have a 14. I want to make those the same. So what can I do? Well, I can multiply the left-hand side by 2 over 2. Remember, that's just multiplying by 1, so it's not really changing the value. It's just changing the form. That's why this can stay equal even though I'm multiplying something, because I'm just multiplying by 1. So it used to be 2/7. When I multiply by 2 over 2, I get 4 over 14. But of course, we know that 4 over 14 is the exact same value as 2 over 7, right? They're both going to be the same value. So it's still going to be equal to the same thing on the right-hand side. Okay, so now I have a common denominator. So I can go back to what I did before, and I can just say, oh, the tops have to be equal. So this x has to be equal to that 4, which makes it pretty simple. It just x has to be equal 4. 4 over 14 on the right would equal 4 over 14 on the left. Same thing as 2/7, okay? Same thing over here. I don't have common denominator, so I need to make one. The left-hand side needs the 2. This one has 2x. This one only has an x. So I need to multiply by 2 over 2. If I do that, I'll get 8 on top, but it'll give me 2x on the bottom, which is the same thing as what I had on the right, which is what I'm looking for. Common denominator. And again, why am I allowed to do that? Because 2 over 2 is only 1. So it's multiplying by 1. It doesn't really change the value of it. It just changes the look of it. right? I could, at any moment, I could just take this 2 and divide it into the 8 and go right back to 4x, 4 over x, right? Okay, so but you don't want to do that, right? So I have my common denominator now. That allows me to just look at the tops and say, what's going to make those equal? 8 equals x minus 1, so add the 1 to both sides, and you will get 9. So let's check it out. Does 9 really work? Well, let's take a look. If I put in 9 there, and I put in 9 here, and I put in 9 here, like forget this for the moment. I'm just going back to the original. So 4 over 9 on the left. That's what I have on the left. And then I'm asking myself, is that the same as on the right? I have 9 minus 1 is 8. And then I have 2 times 9 is 18. Is 4 over 9 the same as 8 over 18? Well, yeah, because I can simplify this fraction, divide by 2, and it'll come down to 4/9. Oh, so it is the same, right? Yeah. So I've checked my answer. I made sure it worked. Life is good. I'm done, right? You can see we can always check our answer. There is another method, which a lot of people like to use. It's called cross multiplying. If you cross multiply, this is allowed, but it's only allowed if you have an equal sign here. I see some people try to do it. Let me go down here somewhere. Yeah, with something like this maybe. And they'll try to like multiply here and multiply here, and they end up with something weird like 24 plus 3x on the left-hand side. You're not allowed to do that, right? You cannot cross multiply just like when you have an expression and you're trying to add, subtract, or multiply, divide. It only works when you have addition or when you have an equal sign, and it only works if you have a fraction over here. Like this is a addition right now. I'm going to have to fix that first before I can cross multiply. But let me go back up here. So this is it's just fraction equals a fraction. It's really important. It's just that. Fraction equals a fraction. That's the only case that you can cross multiply. And so down here in the green is doing that. 2 times 14 gives me my 28. Whoops, you can see that here, right? And then I go 7 times x and get the 7x. And it doesn't matter if the 28 is on the left or the 7x is on the right. It doesn't really matter. When you solve this, you'll get x equals 4, which is the same thing we had up above, right? So you can see how that would work. On the right-hand side, however, when you do cross multiplying, again though, it's fraction equals fraction. There's no like, I don't have another term over here that has some other thing, like with addition or multiplication or something. If I did, I'd have to put those together first before I cross multiply. Okay, but it doesn't have that. It's just fraction equals fraction. You can cross multiply, which they show down here in green. So the x times the x minus 1 right here. And then we got the 4 times the 2x, which is 8x. Right, 2 times 4, 8x. And then we distribute this one out. So x times x, x squared, x times a negative 1, negative x. We can see we go over here. We're going to subtract the 8x from both sides. So subtract it over to the other side. So negative x and then minus 8x will give you negative 9x. And then when you do that, this 8x is gone, so it becomes 0, right? 8x minus 8x just gives you 0. So this is equal to 0 now, and we've done some stuff like this where you're like looking for something equal to 0. So you factor that out, and you can see that I have two pieces now that can make this equal to 0. So when you look at those, if this x was equal to 0, that whole thing would be 0. Or if this piece was equal to, if this x was equal to 9, then 9 minus 9 would give me 0 as well. So this one looks like it has two solutions. It's like, hey, wait a minute. Before I only had one solution. Where's this other solution coming from? Well, it's coming from the fact that you didn't ignore the bottoms. You didn't think about where x is 0 on the bottom. So we have to account for that. In fact, whenever you look at your solutions, part of going back and checking your work is to make sure you don't get any zeros on the bottom. If you get 0 on the bottom, then it's going to be undefined, and you have to eliminate that as a solution because you can't use it if you're dividing by 0. Okay, so be careful of that. It's really something that a lot of people forget to do, is check to see if you have any zeros on the bottom. All right, so in this case, if I put 0 back into my original equation, you'll see here, right, I'm going to get 2 times 0 is going to be 0 on the bottom, and that's going to be divided by 0. Or if I stick it in over here, that's still going to be 4 divided by 0. That's not allowed. You can't divide by 0. It's undefined. So we eliminate that solution. We say it's not one of my allowed solutions. It's not part of my domain, right? We've been talking about domain, and this is where it shows up. That's not part of it. But the 9, however, does work, so that stays as one of my solutions. We've already checked that one, right? So that is one of your solutions. Okay, so that should be like everything you need to know pretty much, right? Try to get it into one fraction, make those fractions have common denominators, and then you can either cross multiply or you can just make the tops equal to each other if you have a common denominator. Let me rephrase that. You can either cross multiply without making the denominators the same, right? Like you can forget the common denominator part of it and just cross multiply. But again, that only works if you have fraction equals fraction. You have to get those into one fraction first. Or you can make the bottom a common denominator and then just look at the tops only. Those are kind of your options. That's kind of your list of things to do, right? Get one fraction, maybe you cross multiply, or maybe you make a common denominator and look at the tops. Last step is checking your work. Check your answers to make sure they don't divide by 0. If they do, you have to eliminate them. All right. So nothing new from this point on. It's just going to be repeating that. I think this one's pretty straightforward. I'm going to kind of go quickly through these. So this is just kind of a version of cross multiplying. I have an x on the bottom, so I'm just going to multiply both sides by x to get rid of it on the bottom. This one has x plus 1 on the bottom. I'm multiply both sides by x minus x plus 1, and then you just solve like normal. Check your answers to make sure you're not dividing by 0, though. All right, this one you see we have two fractions. I cannot cross multiply until I put those fractions together. So you're going to see down here, in this case, we did not, we're not worried about cross multiplying. So we're leaving those as two separate fractions, and I'm getting a common denominator. If you have a common denominator, you can just take the tops, right? You can't cross multiply, but you can take those tops and just solve the tops. Again, check your work, make sure it works. Same thing here. In the end, we are not going to cross multiply for this one. So I can just leave this. I can just leave this as a two different fractions, right? And then we're going to get a common denominator instead. So you can see we're making this one a 2x like the other ones, right? These are 2x. And then after that, you can put your tops together and make those equal to each other. And you can kind of ignore the bottom because we have a common denominator, and then solve. Don't forget to check your work. Okay, one last thing. Here's one where we do cross multiply. I could find a common denominator if I wanted, but this is an example of where you don't find a common denominator and you just cross multiply instead. So we have the 3 times the x plus 2 over here. You can see that. And then we have the x times the 2x plus 4. You can see that there. And again, it's fraction equals fraction. That's the only reason I can do it. Distribute that through, distribute this through. We're going to move everything to one side so that it's equal to 0. So we have to subtract 3x from both sides, and that will give me a positive 1x, 4 minus 3. And then I'm going to subtract 6 from both sides. That just stays the way it is. And now I have something equal to 0. So the goal here is to factor this out. And when you factor that, then you can get your two solutions from that. So we want to know where this piece is going to be 0, which is what we're doing here. And then we want to know where this piece is going to be 0, which is what we're doing here. So when you separate those out and you just say, okay, what value of x makes this 0? It ends up being 3 over 2. And then I say, what value of x for this piece makes it 0? And that would be negative 2. Again, you got to check your work. Just go back and make sure that if I put that x in here, it's going to work, right? And I'm also checking to see that I'm not dividing by 0. Negative 2 on the bottom here, and that's not going to be a problem. 3 over 2 on the bottom here, not going to be a problem. But I'm still going to want to put it in, right? Put it in for all the x's and just make sure that the left side and the right side are equal to each other. That's the whole point, right? They're equal, so we're solving to say that these have to be equal. All right, last problem. These, they went through the process, instead of cross multiplying, like you couldn't cross multiply anyway because you have two fractions. So they're saying it's just going to be easier to find common denominator anyway. So this one gets factored first, so I can see what that common denominator is. So we factor that first. Then I can see from that, I can see that this one needs an x minus 5, and I can see that this one needs an x minus 6. So we should be multiplying by x minus 5, x minus 6. This should be minus 6. It looks like someone wrote plus. Oh, they have it correct down here though. Okay, so x minus 6 on both of those. Okay, and then you have your tops, right? This is just 1 times x minus 5. Then we have x times x minus 6, x times x minus 6, and then we have 1 on top here, 1. So once I got my common denominator, I can ignore the bottom then and just work with the top. It still ends up as a quadratic. You have to factor, and then you're still going to get 2 solutions. And then this one, you're going to see that we do have an extraneous solution. That's 6. If I put 6 back into here, I'll get 6 minus 6, and I'll be dividing by 0. That's not allowed. It's undefined. So I'm gonna eliminate that solution and say, that's like a false solution. We call it extraneous. Okay, and then the negative 1 does work. There's no problem with the negative 1 anywhere. I can go ahead and put that in all the x's to make sure it works if I want. And you can check your answers. Okay, that's good for solving rational equations. Waka waka, breaking it down.